You've very likely interacted with magnets before, but do you know what causes them to be attracted to other magnetic objects? Why some materials are magnetic but many aren't? My name is Isabel, and this video will explain all that. Every magnet has both a north and south magnetic pole. If you were to cut a magnet in half along the division of the poles, the two pieces would each have their own north and south pole, and so on.
When two or more magnets are brought close to each other, their magnetic fields interact. Opposite poles, north and south and north, attract, while similar poles, south and south or north and north, are repelled. But why? When electrons spin around the nucleus of an atom, of which everything is made out of, the atom can become a tiny magnet complete with poles and a magnetic field. So why aren't all materials magnetic? Either the electrons are not arranged in such a way as for the atom to have magnetic properties, or the north and south poles of the object's atoms are all pointing in different directions, and so the overall object is not a magnet. At least one of these are the case in non-magnetic materials such as wood, plastic, and many more. In many cases, parts of the object, called magnetic domains, have the same magnetic orientation, but the individual domains are still in different directions. However, some types of material like this can be magnetized if they are put on a magnetic field, which causes all the domains to align and therefore make the object a magnet. Materials that are capable of this transformation are called ferromagnetic materials. This conversion can be temporary, such as when a magnet attracts a paper clip, which can then collect other objects so long as it remains touching the pole of the magnet, or permanent, such as stroking an iron nail with a bar magnet, in which case the former will become an at least long-lasting magnet. Permanent magnets can be demagnetized if they are dropped or heated, which will cause the magnetic domains to unalign again. Earth actually has its own magnetic field and poles as well. Imagine a bar magnet with north and south ends going straight through the Earth. Because of Earth's slight tilt, the magnetic poles are in slightly different places than the geological poles. These poles are what allows compasses to work. So if opposite poles attract, why don't compasses point south instead of north? Well, the magnetic north pole is actually at the bottom of the Earth, near the geological south pole. The names were switched to avoid confusion.
The effects of magnetics are all around us, from helping cause the northern lights to innovative use in engineering, such as in maglev trains. So, next time you use a compass or refrigerator magnet, think about the processes that have to happen to make them work.